In this video, I'll show you how I use Terraform and Ansible together to automate Kubernetes node preparation on Proxmox. The goal here is not just to create virtual machines, but to build a repeatable workflow where the infrastructure is provisioned first, and then each machine is automatically configured with Docker and the core Kubernetes tools. If you're building a home lab, preparing for Kubernetes certifications, or just trying to understand how infrastructure provisioning and configuration management fit together, this project is a practical example of that full flow. I'll walk through the repository structure step by step, show what each directory is responsible for, and explain how Terraform hands everything over to Ansible to finish the setup. In this project, the repository is split into two main directories. Terraform Env handles virtual machine creation, and Ansible handles the machine configuration after the VMs are online. At the root level, this repository is positioned as a Kubernetes lab and certification preparation project. The main idea is simple. Provision Debian virtual machines first, then configure them with the tools needed for Kubernetes work. I'll start with the Terraform side because this is the entry point for the whole workflow. This directory is responsible for talking to Proxmox and creating the virtual machines. The Terraform documentation explains the intended workflow very clearly. This setup creates Debian VMs on Proxmox, supports small, medium, and large machine profiles, and can automatically hand the machines off to Ansible after provisioning. The deployment is driven through Terraform variables. I can choose the VM size, define the IP addresses, set the gateway, pick the SSH user, and provide the SSH keys that will later be used by Ansible. In variables.tf, all of the inputs are declared. This includes the Proxmox API endpoint and token, the VM name prefix, the starting VM ID if I want one, the number of machines, the machine type, the template ID, and the network settings. There's also a useful validation here. Terraform checks that the number of IP addresses matches the VM count. That prevents one of the most common mistakes when creating multiple nodes at once. In main.tf, the first thing defined is the provider configuration. This is what lets Terraform authenticate to Proxmox and manage resources through the API. Right after that, the project defines three reusable machine profiles: small, medium, and large. Each one maps to a different amount of CPU, memory, and disk space. This makes the configuration flexible without duplicating resource definitions. Terraform then builds a list of virtual machines dynamically. By default, it creates three nodes and names them in sequence, like K8s node 01, K8s node 02, and K8s node 0302, and K8s node 03. Each node is also paired with one of the IP addresses passed in through variables. This is the actual VM resource. Terraform clones each machine from a Proxmox template, applies the chosen CPU, memory, and disk settings, attaches a network interface, and assigns the final machine name. The important part here is the cloud init style initialization. This is where each VM gets its IP configuration, gateway, DNS server, username, and public SSH key. That means the machine becomes reachable immediately after it boots, without manual login or setup. After the VMs are created, Terraform generates an Ansible inventory file automatically. This file is written into the Ansible directory and contains all the new nodes with their IP addresses, SSH user, and private key path. Terraform then pauses to wait until SSH is actually available on all of the machines. This is a practical step because VM creation finishing in Proxmox does not always mean the operating system is fully ready for remote access. Once SSH is reachable, Terraform launches the Ansible Playbook automatically. So Terraform is not only provisioning the infrastructure, it is also orchestrating the handoff into configuration management. Now I'll switch over to the Ansible side. This part of the repository is responsible for turning plain Debian virtual machines into Kubernetes-ready nodes. The Ansible documentation describes the role of this folder very clearly. It targets the VMS inventory group and applies a role called Docker_K8s, which contains all the machine preparation logic. In Ansible.cfg, the local inventory file is set as the default inventory source. Host key checking is disabled, which simplifies first-time connections to freshly provisioned machines, and temporary Ansible files are directed to /tmp. The playbook itself is intentionally small. It targets the VMS group, runs with privilege escalation, and applies one role, Docker_K8s. This keeps the project easy to read because the real provisioning steps are isolated inside the role.
The defaults file contains the baseline Kubernetes version and the list of Kubernetes packages to install. Right now, that includes kubelet, kubeadm and kubectl, along with the default DNS server value. This task file is the core of the machine configuration. It starts by making sure DNS resolution works correctly, because package installation will fail quickly if name resolution is broken on a newly cloned machine. Next, Ansible updates the apt cache and installs basic dependencies like transport support, certificates, curl, GPG and other tools that are needed before adding external package repositories. After that, swap is disabled both immediately and persistently. This is a standard Kubernetes requirement because kubelet expects swap to be turned off for stable cluster behavior. The role then ensures that the overlay and BR netfilter kernel modules are loaded. These are important for container networking and for proper packet handling on Kubernetes nodes. The next step applies the required sysctl settings. These enable IP forwarding and make sure bridged network traffic is visible to IP tables, which is essential for Kubernetes networking components. This role also includes a Debian Trixie-specific workaround for the apt sequoia policy. That tells me the project has been adjusted for real package management issues that can appear on newer Debian releases. Once the system is prepared, Ansible adds the Docker repository. It downloads the GPG key, stores it in the keyrings directory, and registers the official Docker apt source for the detected Debian release. The same process is repeated for Kubernetes. Ansible downloads the repository key, converts it into a keyring, and adds the Kubernetes package source based on the configured version. With both repositories configured, the Playbook installs the container runtime stack. That includes Docker itself, containerd, and related Docker plugins. It then installs kubelet, kubeadm, and kubectl, and immediately marks those packages as held. That's a useful safeguard because it helps avoid accidental upgrades that could cause version mismatches later. After installation, Ansible makes sure both Docker and containerd are enabled and started. This means the machine is ready to run containers as soon as provisioning finishes. The last steps add the SSH user to the Docker group and remove the temporary Kubernetes key file. So the role finishes by leaving the machine in a cleaner and more usable state. When I put both directories together, the full workflow looks like this. Terraform clones Debian VMS in Proxmox, injects network and SSH settings, generates the Ansible inventory, waits for SSH, and then Ansible installs Docker and the Kubernetes tools on every node. If I want, I can also stop the process after infrastructure creation by setting run_Ansible to false. That gives me the option to separate provisioning from configuration when debugging or testing. One important note is that this project prepares Kubernetes-ready nodes, but it does not yet initialize a control plane or join workers into a full cluster. So this repository is focused on provisioning and node preparation, which makes it a clean base for labs, demos, and future cluster bootstrap automation. That's the full structure of the project. Terraform handles the infrastructure lifecycle, Ansible handles the operating system and package setup, and together they create a repeatable foundation for Kubernetes practice on Proxmox. That's the complete walkthrough of this project. As you've seen, the main value of the setup is that it turns a multi-step manual process into a repeatable workflow. Terraform creates the Debian virtual machines in Proxmox, and Ansible prepares them as Kubernetes-ready nodes. This gives you a solid starting point for labs, demos, and future cluster bootstrapping, while keeping the infrastructure layer and the configuration layer cleanly separated. If you want, in a follow-up step, this project could be extended to initialize the Kubernetes control plane, join worker nodes automatically, and turn these prepared machines into a full working cluster. Thanks for watching.